Hi, this is an example of thick dielectric dipole antenna. First thing we need to start is the cylinder. Okay, now this antenna has a length of 13.65 centimeter and the radius of 0.75 centimeter. I calculated for 1 gigahertz. So let's try it. Cylinder. Major radius is going to be 0.75 centimeter, but remember this is in millimeter in SAMCAT, so 7.5 millimeter is the right value. Now, what I'm going to do is I'm going to have, again, the entire antenna geometry is going to be 13.65, but I'm going to have a 0.5 centimeter as a for the feed. Okay, so what I'm going to do is 6.5. That's the entire length, but I'm going to subtract 5 millimeter. Okay, so now let's see if we can do this. Divided by 2. Okay, because we are going to have 2 conductors instead of 1 conductor. Alright, so that works. Okay, now I'm going to apply it. Okay, I'm going to make a clone. Now we have these 2 cylinders overlap each other now. Let's move one of them to the lower place. Okay, so it was, again, by how much? It will be a 13.65, actually in millimeter, that's that. And I'm going to have a minus 0.5 millimeter, which is 5, and divided by 2. Okay, we're going to move that much. There we go. Okay, now as you can see, there are 2 wire or cylinder in this case overlap each other. But remember, we have to have some feed in between. So I'm going to move each of them by 0.25 centimeter. So let's go from the first one. Okay, and moving 0.25 centimeter, which is 2.5 millimeter. Okay, that was wrong. We gotta have minus. Okay, now this is right. Okay, now for this one, we're going to move down by 0.25 centimeter. And that's it. Okay, now we have a 13.65 centimeter from here to there and having gap of 0.5 centimeter. Okay, so I'm going to save it as thick dipole. Okay, now next thing we need to do is to put the feed. Okay, so either you can grab from value from here, the point from here, or you can just where we're supposed to put it. So xy is supposed to be 0, y is minus 2.5 millimeter, again plus 2.5 millimeter. Let's see if we, okay, there we go. So we just have one edge source. Okay, let me zoom in inside right there. See, we have a nice feed here. Okay, now next thing we need to do is go there, setting. I'm going to have a, instead of a harmonic, I'm going to have a broadband. Okay, we are going to run broadband simulation in this case. Broadband, the bandwidth is just set it to 1 gigahertz as default, that's fine. Now go to cylinder, solid region, click cylinder, make it PEC, perfect electric conductor. Make another PEC, perfect electric conductor. Okay, and save it again, just for in case. Now you gotta make sure that we have enough sine wave. Well, not actually, this is not a sine wave, this is what is called a modified Gaussian pulse. And this is a broadband. Okay, so what I'm gonna do is, since we have very short period here, I want to have enough time. So let's go back to setting. Okay, and remember we want to have 100 period all the time, and make sure this thing is the automatic stop function is clicked on. Okay, so now there we go. We have a long time, enough time to all the signal decays. Okay, lumped element, nothing. Sensor, nothing. Make sure that we have far field turned on. If you click this one, it's off, and you will see a red cross here. But we want to have far field this time. Okay, boundaries. This looks good. Now go to grid. Okay, this is one thing that you never done. If you look at the mesh here, see there is just 1, 2, 3 lines. If we think about the concept of Lego, we only have 2 Legos here. Okay, this is going to be a problem. It will make really rough. Not the cylinder, but it will make a rectangular antenna. So what I want to do is I want to have a little bit more realistic looking. Okay, first thing you need to do, go to background and change this wave unit length type into millimeter. Okay, so this one is better because now all the units you're going to see is going to be millimeter instead of the wavelength, electric length. Go to cylinder. Okay, you just have to do once here. Go to click on use local settings. Click here. Okay, now what you can do is you can actually do some more fine mesh. What I'm going to do is I'm going to have a X and Y axis, which actually is this axis. See, you only have 4 meshes here. I want to have much more meshes. Now, again, look at the axis. This is X and Y plane. Now I'm going to change this X axis by setting max stat as 0.3 millimeter. Boom. See, we have so many meshes now. Not so many, but actually we have too many meshes here. I'm gonna make it to 3 millimeter. Okay, that makes a little bit more sense to me. Now make another one, which is y-axis, as 3 millimeter. Okay, now we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so this one is not really perfect circle, but still it represents a little bit better. Okay, that's what we call a staircase approximation. Let's see how it works. Okay, now you just have to mesh it. Right click, voxel, make a voxel. Okay, now what I'm going to do is I'm going to go to right click on voxel again. And look at how your mesh really look like. View voxels. Okay. Now what I'm going to do is I'm going to remove this show original mode. Okay. That's see, if you click this one, what you're seeing is your CAD geometry, not the mesh geometry. So click that and remove that checkbox, and you will see how it is meshed. Again, this is not really perfect circle, but just for our purpose, this is just enough. Okay. That's your geometry. So if you see some discrepancy or some errors in visual, you can probably think that, well, that's not because it's not really perfect circle. Okay, that could be one of the excuses, and it's a very well known problem in this kind of simulation tool. Now I'm going to run the simulation. Let's see how much it takes. Okay, it's running really fast, so we're good. Okay, we're done. Took me like 5 seconds or something. Now go to result, go to far field. Oh, the far field is not really calculated. In this case, we have to get the single frequency simulation to get the far field. Now, What I'm going to do is I'm going to go to sensor at source. I want to see how the S11 parameter look like, which is the reflection coefficient. There we go. See, we have 0.9 instead of 1 gigahertz. There was 100 gigahertz, 100 megahertz difference. Okay, that's what it is. It could be because we didn't get 1 gigahertz because the mass is not really perfect. There could be several reasons why. But 100 megahertz is not too bad. You can just further optimize the geometry to make it perfect. Okay, so that's that. One more thing that I'm gonna do is go to simulation. Okay, now go to clone. Now this is the second simulation tools that you got here. What I'm gonna do is I'm going to go to setting. Okay, and then instead of having broadband, I'm going to have a harmonic at 0.9 gigahertz that had really good S11 parameter. Okay, so do the same thing for everywhere. Source, make sure everything is good. Lumped element, make sure this is now sine wave instead of Gaussian pulse. Okay, and sensor, band, grid. Okay, you have to click the grid first. I'm gonna go over here again. Okay, we still have six in this side, 6 in that side, so we're good. Voxel. Okay, I'm gonna go to view voxels. All right, so that looks okay to me. I'm gonna run it again. We're done. That's fast. Now, far field. There we go. Okay, go to click on far field. Click on 3D far field, theta pi. Right click on it. Click spherical field view, and you will see something like this. Just ignore it. Go next. There we go. This is your radiation pattern for this antenna. Okay, I hope this example helped you to understand how to make this geometry and how to get that 3D far field. Thank you very much.